Hello friends, welcome back to C Level Physics. My name is Srinivas, known to be BS Rao. I requesting all the audience and subscribers to please stay tuned to C Level Physics, which is meant for foundation level at the rate of cbse, icse, igcse, including class 11, class 12, NEET, IIT, JEE, mains and advanced aspirants. So presently we are in relative motion concept, right? We know that equations of motion. What are the equations of motion? See here, equations, general equations of motion. First one, V equal U plus AT. Second one, S equal UT plus half H square. And third one, V square minus V square equal to AS. Okay. But here, in this side, transformed equations of motion. Relative concept means relative motion concept. So in that concept, if you want to use equations of motion in case of relative motion or relative velocity, same can be transformed into V relative equal to U relative plus A relative into T. First expression. See here, V equal to U plus AT. Of course, this one also V equal to U plus AT1. But here, velocity of one body with respect to another body. Similarly, initial velocity of one body with respect to another body. Final velocity of one body with respect to another body. Right? Similarly, relative displacement. Okay, but time is absolute. That's why no relative for time. Right? So here first equation V equal to U plus AT, but here V relative equal to U relative plus A relative into T. Means final relative velocity equal to initial relative velocity plus relative acceleration into time. Right? Second expression. See here S equal to UT plus half H square. But here also S equal to UT plus half H square. But here S means S relative, U means U relative, T absolute plus half into A relative into T square. Same expressions but a small modification. Right? Third one, V square minus U square equal to 2AS. But here also V square minus U square equal to 2AS. But here V becomes V relative, U becomes U relative, A becomes A relative, S becomes S relative. Okay. Let us see some illustrations based on relative velocity concept. Here, say one example. A car is moving at a speed of 30 meters per second when driver suddenly sees a truck that is moving in the same direction at 10 meters per second and is 60 meters ahead of car. If reaction time of driver is 0.5 seconds, what deceleration brakes of car should produce to avoid collision? See here, this is a track on which car and truck both are moving. So here, this is what car. What is the speed of the car here? That is 30 meters per second. 30 meters per second. This is what one truck whose speed is 10 meters per second. That is 10 meters per second. Right? Now, what is the initial separation between car and truck here? 60 meters. See, truck is ahead of 60 meters from the car. Right? Here, the car driver observes as truck is ahead of 60 meters and moves at a speed of 10 meters per second. Right? So to avoid accident here, car driver applies brakes. But here one reaction time is there for the car driver. What is the reaction time here? Means that is the time interval between an observing truck and application of brakes. Right? That is the reaction time. What is the reaction time for the car driver here? 0.5 seconds. Right? So on watching truck ahead of him, he didn't apply brakes immediately. There is some reaction time for the car driver to apply brakes on watching the truck. So what is that reaction time? 0.5 seconds. So within that 0.5 seconds, definitely car advances this much of distance, right? From here to there, this much of distance. So this is what distance covered by the car. Of course, truck also moves forward in that 0.5 seconds, right? Of course, this is the actual distance between car and truck, but from here, truck also advances through some distance within that 0.5 seconds, right? Now, what is this distance? That is this distance equal to speed into time. That is, what is the speed here? 10 meters into time. Time means 0.5 seconds. So 10 into 0.5. Distance equals speed into time. So that is what 5 meter. But here, what is the distance covered by the car within that 0.5 seconds just before application of braking force here. That is what this is what means x equal to speed into time. So speed equal to 30 into time in 0.5 seconds. That is what 30 into 0.5, that is 15 meters. Right? See, of course, this is the initial separation between car and truck, but within that reaction time, car advances through some distance, that is what 15 meter. In the same time, truck also advances from the initial position through a distance of 5 meters. Now, what is the actual separation in reality here between these two means? Actual separation S relative equal to, what is S relative? Initially 60 plus what is the distance move forward by the truck, that is what 5 meters. So 60 plus 5 minus what is the distance covered by the car, that is what 15 meters. Right? See once again, what is initial separation between car and truck here? 60 meter. Right? Okay. By that time when braking force is applied by the car driver, what is the actual separation between the car and truck means? See, 60 plus 5 minus 15. So 60 plus 5 minus 15. So 60 plus 5 means what? Distance move forward by the truck minus what is 15 here? Distance move forward by the car, that is 15. Right? So that is what 60 plus 5 minus 15, that is what 65 minus 50, that is 65 minus 15 means that is 50 meters. Right? 50 meters. Okay, 65 minus 15, that is 50 meters. This is what relative separation by that time when brakes are applied. Right? This is what relative separation between car and truck by the time when brakes are applied by the car driver. Now the question is, what deceleration brakes of car should produce to avoid collision? Right? So if accident not to occur, then definitely car driver must apply some brakes. Right? So before hit by car, the truck must be escaped. Right? Right? So that means to say that car has to retard just before hitting truck. What is that retardation? That is the question. So see here, we know that v square minus u square equal to 2as. V square minus u square equal to 2as. Right? Okay. Suppose here accident not to occur means the final relative velocity of car with respect to truck must be 0. Right? Before comes to halt, right? The separation between car and truck must be non-zero. Means the final relative velocity of car must be 0. That is, in case of relative terms, v relative minus p relative whole square minus u relative whole square equal to into a relative into s relative. That is, v relative means v car minus v truck whole square minus u relative means u car minus u truck whole square equal to 2 into a car minus a truck into s relative. Right? That is what Vc minus Vt. What is the final relative velocity of car with respect to truck means? It has to come to rest. Right? So therefore final relative velocity is 0. So 0 minus Uc minus Ut. These particulars are initial velocities. So Uc means 30, Ut means 10. That is 30 minus 10 whole square equal 2 into Ac minus At. So AC definitely it must retard. Therefore AC as it is. AC minus AT means 0. Why? Because it is moving at the same rate, that is 10 meters per second only. No acceleration for truck. So AT is 0 into S relative. What is S relative here? S relative means 50 meters. right? That is 30 minus 10 means 20 minus 20 whole square means minus 400 equal to 2 into 50, that is 100 into s. 100 into s. That is minus AC equal to 2 zeros cancel. We left with minus AC equal to 4 meter per second square. This is what minimum retardation. The minimum retardation or minimum deacceleration brakes of car should produce to avoid collision. So, in fact, this retardation must be greater than or equal to minus AC either greater or equal to 4 meter per second square. Right? If minus AC is exactly equal to 4 meter per second square, that means to say that the collision, otherwise the accident just escaped, right? But minus AC greater than 4 means well escaped from the accident. Okay. Now let us see one more example. Most general example, that is what a policeman catching thief. This is most general example. Okay. Right? See next example. Here on policeman, right? On policeman, P stands for police, finds one thief who is running away from policeman with initial velocity 0 and acceleration equal to 2 meter per second square. Right? In order to catch that thief, policeman also running at a constant speed. What is the speed of policeman? That is 20 meter per second. So, policeman running at a constant speed of 20 meter per second in order to catch that thief who is just starts its running at a constant acceleration of 2 meter per second square. So, initial velocity of thief is 0, acceleration of thief is 2 meter per second square. Right? So, with these particulars, suppose policeman catches thief somewhere here. Somewhere here. So, policeman catches thief somewhere here. Alright, policeman, thief. Now, what is the initial separation between these two means? That is what? 100 meters. So, this is the initial separation between policeman and thief. Right? See, once again, the particulars of policeman and thief. A constant speed of policeman is 20 meters per second. The initial velocity of thief is 0. Acceleration of thief is 2 meters per second square. See, this 100 meters is initial separation between policeman and thief. Right? Now, method 1, that is relative concept. Relative velocity concept. Relative velocity concept. Right? Now, what is the separation here? 100 meter. 100 meter. So, here relative separation between these two, 100 meter. Right? Initial, that is relative velocity of policeman with respect to thief is 20 minus 0. 20 minus 0. Right? Now, the question is, in what time the policeman catches thief? Find the time in which policeman catches the thief. That's what unknown. We need to find that time, right? So here, relative method, what equation is employed here? S equal to ut plus half h square. Why? Because here relative velocity is there, that is 20 minus 0, right? Acceleration also there. So we need to find time. So separation also there. Now, which equation of motion is to be employed here means S equal to ut plus half h square. So we know that S equal to ut plus half at square. But in terms of relative concept, S becomes S relative, U becomes U relative, time is absolute. Don't write time for relative. That is half at square, half plus half into A means A relative, right? So S relative becomes equal to U relative T plus half A relative into T square. Simply S equal to UT plus half it. What is the relative separation between these two? What is the relative separation here? That is 100, right? 100 equal to U relative. What is the initial relative velocity of policeman with respect to thief? Means that is U police minus U thief into T plus half into A relative means A police minus A thief into T square. Right? See, both are running in the same direction. Both are running in the same direction. Therefore, relative velocity means U police minus of plus U thief. U police minus of plus U thief means UP minus UT. That is 100 equal to U police means 20 minus U thief. What is the initial velocity of thief? 0 into time unknown plus half into A thief. What is the acceleration of thief here? Sorry, A thief equal to A police is 0. That is acceleration of police is 0. Why? Because he is under uniform motion. So 0 minus A thief is 2 meters per second square. That is 100 equal to 20t. 2 cancel, right? Minus t square plus or minus t square. So carry this t square and LHS t square equal to implies otherwise t square equal to t square minus 20t plus 100 equal to 0. Right? T square minus 20t plus 100 equal to 0. Quadratic expression. Right? Here compare with the ax square plus bx plus c. So here A means what? 1 into t square means 1. B means what? Minus 20. C means what? 100. Now how to find roots for time? T equal to minus b plus or minus root over b square minus 4a square 2a. So minus b plus or minus root over b square minus 4ac whole divided by 2a. Right? That is t equal to minus b. Minus b means minus b equal to 20 plus or minus root over b square. Root over b square means minus 20 whole square. That is 400. Minus 20 whole square means 400 minus 4ac. 4 into a means 1, c means 100. So 4 into 1 into 100, that is 400. 400 by 2 into a. A means what? 1. 2 into 1. So 400 minus 400, 0. Root 0 means 0. That is, we left with the 20 by 2. So t equal to 20 by 2, that is 10 seconds. 10 seconds. So within 10 seconds, policeman will catch thief. Right? This is what time. In 10 seconds, definitely he will be caught by policeman. Right? Of course, in general method also we can find same solution. See, general method, method 2. General method. How to find general method here? See, suppose what is the initial separation between these two? 100 meter. 100 meter, right? What is the constant speed of policeman? 20. So, suppose here policeman catches thief somewhere here. Now, what is the distance covered by the policeman from here to there? Means that is what? From here to there. From here to there. What is the distance covered by policeman? Distance equals speed into time. So speed 20. 20 into time. Right? So this is what total distance covered by the policeman just before he is going to catch thief. Right? Now at the same time, what is the distance covered by the thief from here to there just before he was caught by policeman? That is half h square. U0, but he is under acceleration, therefore s equal to ut plus half h square. U equal to 0, therefore s equal to half at square. Half at square. This is what distance covered by the thief. Distance covered by the thief. Right? Half at square. This is what distance covered by the policeman. 20t. Right? 20t. See here, I am observing 20t becomes equal to 100 plus half at square. See once again. total distance covered by the policeman equal 20t, that must be equal to initial separation 100 plus distance covered by the thief just before he was caught by policeman. So 20t equal to 100 plus half 8 square. 100 plus half 8 square, right? That is 20t becomes equal to 100 plus half into 8. What is the acceleration of thief here? 2 meters per second square. 2 meters per second square. Right? 2 to cancel. We left with the t square plus 100 minus 20t becomes equal to 0. So t square, take this, carry this 20t onto RHS, that is t square minus 20t plus 100 equal to 0. See, same expression or not? T square minus 20t plus 100 equal to 0. So here onwards, solution will be same. So on proceeding in the same way, finally you will get t equal to 10 seconds soon. Right? See, here also t square minus 20t plus 100 equal to 0. Here also t square minus 20t plus 100 equal to 0. So up to here same only. So we can proceed in the same way to find time here onwards. So this is what general method. This is what relative concept method. Okay. But here some points are there to worth note. Means, of course, sometimes time finds two routes. Here we have only one route. In some cases, we will get two routes. That is T1 equals so and so, T2 equals so and so. In that case, what is the inference? Means the policeman will catch the thief twice. First at T1 and next at T2. Right? It doesn't mean that thief was left by a policeman. Simply, except it is just like running race. Right? So in that case, policeman will meet twice. Will meet the thief first at T1 seconds and next at T2 seconds. That is the meaning. It doesn't mean that thief was left by policeman. Okay. Now, in some cases, there will be imaginary term while finding time. There will be imaginary term. Suppose root over negative term. Root over negative term in the sense, root over negative term has no significance in reality. Means that is what imaginary. So in that case, what is the inference? Means policeman will never catch the thief. That is the meaning. Right? So in that case, he has some closest distance of approach from the thief. The case in which he fails to catch the thief. Right? Let us see those points. Right? So what is the inference here? First point, what is the point here? If T finds two routes that equal T1 and T2. If T finds two routes, what is the meaning? T equal to either T1 or T2 means policeman catches thief twice. First at T1, next at T2. Say T1 is less than T2. Say T1 is less than T2. So therefore, what is the reference here? Policeman catches thief twice, first at T1 and next at T2. That is the meaning. Provided T finds two routes, right? In some cases, you will get one imaginary term in finding T. If T is imaginary, implies that what can we say here? Means policeman will never catch thief. Means policeman will never catch thief. Will never catch thief. Right? That is the thing. Will never catch thief. Right? And next one. In that case, if he fails to catch thief, definitely he has some closest distance of approach from the thief. So, if policeman fails in catching thief, if policeman fails in catching thief, he will have some closest distance of approach. Right? He will have some closest distance of approach for the policeman from the thief. Right? Now, let us see this example. Right? If t is imaginary, let us see even that example also. Suppose, what is the speed of policeman here? 10 meters per second. 10 meters per second. Alright? Okay. But here these particulars are say initial velocity of thief is 0 and acceleration is 2 meters per second square. So s equal half 8 square. Alright? Initial separation 100 meter. Okay. So everything is same except the speed of policeman. Right? Change it from 20 meters per second to 10 meters per second. Now let us see that example also. Right? What is the relative equation? S equal to ut plus half at square. Half at. That is S relative equal to u relative into t plus half into a relative into t square. What is the S relative between these two means 100. Right? Okay. So 100 equal to u relative. Relative velocity of policeman with respect to thief is, that is 10 minus 0. So 10 minus 0 into t plus half into a relative. Relative acceleration of policeman with respect to thief, that is here 0, acceleration is 0. Right? 0 minus 2 into t square. Right? That is 100 equal to 10t. 2 to cancel minus t square. That is t square minus, take this term onto LHS, that is minus t square becomes plus t square plus 10t becomes minus 10t plus 100 equal to, right? So here a means what? 1, b means what? Minus 10, c means what? 100. So a equal to 1, b equal to minus 10 and c equal to 100. So what is t here? T means minus b plus or minus root over b square minus 4ac by 2a. That is t equal to minus b means minus or minus b equal to minus 10 minus b equal to 10 plus or minus root over b square means minus 10 whole square, that is 100 minus 4ac. 4ac, 4 into 1 into 100, that is 400 by 2 into a, 2 into 1. So this is what? Time. See here, root over 100 minus 400, that is root over minus 300. T equal to 10 plus or minus root over minus 300 by 2. So in this expression, root over negative term has no significance in reality. So this is what? Imaginary. So this term is imaginary. Root over negative value is imaginary. It has no significance in reality. Okay, right? That means to say that as we are having imaginary term involved here, that means to say that the policeman never catches thief in this case. But in this case, he has closest approach. Of course, he fails in catching thief, but he has closest approach, right? He has closest approach from the thief. even though he fails in catching the thief, right? Now, how to find that closest approach means here some steps are involved. If you want to calculate the closest approach when he fails catching thief, right? Let us see. Let us see. What are the steps involved here? What are the steps involved? Closest approach. So in the same example, find the closest approach of policeman from the thief. From the thief. So he fails in catching thief. So I am rubbing off here. Okay. Right. Of course, what is the acceleration of thief here? Acceleration equal to 2 meters per second square. Right. Initial velocity 0. Here steps involved. What are the steps here? Step 1. Step 1. Thief is assumed to be stationary. Thief is assumed to be stationary. Of course, with respect to ground, he is running at a constant rate 2 meters per second square. But if you want to get closest approach of P from T, we have to assume that T is stationary. Right? Even though he is running, we have to assume that T is stationary. So T is assumed to be stationary. Right? Okay. Now step 2. Step 2. Find acceleration of policeman with respect to thief. So acceleration of policeman with respect to thief is equal to A police minus A thief. Right? A police with respect to acceleration of policeman with respect to thief equal to acceleration of policeman minus acceleration of thief. Of course, these are absolute accelerations, means with respect to ground. With respect to ground. Right? So that's what APG. What is acceleration of policeman with respect to ground? 0. So 0 minus acceleration of thief with respect to ground, that is what? 2 meters per second square. Right? That is APT equal to minus 2 meters per second square. Right? So in step 2, what shall we find? Acceleration of policeman with respect to thief. By keeping thief is stationary, even though he is under motion. Right? So from this, what is the inference? Acceleration of policeman with respect to thief is minus 2 meters per second square, in the sense, even though the acceleration of policeman with respect to ground is 0, with respect to thief, he is under retardation. See, here we have negative sign for acceleration of thief. Means, what is the reference? With respect to thief, policeman is under retardation. Of course, with respect to ground, he is under uniform motion. But with respect to stationary thief, he is under retardation. He is under retardation means his speed change is decreasing at a constant rate of 2 meters per second square. Right? At a constant rate of 2 meters per second per every second. That is 2 meters per second square. So 10 meters per second is not at all constant with respect to stationary thief. Right? So implies policeman is under retardation. Under retardation with respect to stationary thief. Right? So with respect to stationary thief, P is under retardation. Right? So as P is under retardation with respect to the stationary thief, after some time he comes to rest also. Policeman comes to rest after some time, right? Because speed decreasing at a constant rate. So what about final relative velocity of policeman with respect to thief? 0, definitely 0. Why? Because he is under retardation with respect to stationarily assumed thief, right? So he is under retardation, means his speed gradually decreasing and even comes to halt also. So therefore, final velocity of policeman with respect to thief must be equal to 0. But what about initial velocity of policeman with respect to thief? That is 10 minus 0. So initially 10 meters per second. Here 0. Now relative speed is 10 minus 0. 10 minus 0, that is 10 in this case, right? Now in that case, before his relative velocity vanishes, before the relative velocity of policeman with respect to thief vanishes, he must cover some distance. That's what relative distance covered by the policeman with respect to thief. So S relative, here S relative is question mark. S relative is question mark. S relative is question mark. See, policeman, you policeman with respect to thief, that is 10 rate per second is policeman, right? So here stationarily assumed thief, that is thief, whose velocity is 0, that is u thief equal to 0. U thief equal to 0, right? But he is under retardation. What is the retardation of policeman here? Minus 2 meters per second. A policeman with respect to thief, that is minus 2 meters per second. So finally, his speed gradually decreasing and vanishes here. So here policeman comes here, right? V policeman with respect to thief is 0. V policeman with respect to thief is 0 here. Now this is what S relative displacement caused by the policeman from the thief, right, before his relative velocity vanishes. So this is the relative distance. Now this becomes closest distance of approach. Closest distance of approach. See here, same only written somewhere here, right? So here's what policeman. U police with respect to thief, that is 10 meters per second. What is the retardation here? A police with respect to thief, that is minus 2 meters per second square. But he is under retardation with respect to stationary thief, that is u thief equal to 0, right? So gradually his speed decreasing and becomes 0. What is the initial separation between these two? That is 100 meter. 100 meter, right? 100 meter. Now, before his relative velocity becomes 0, policeman reaches somewhere, right? So this distance is what? S relative. S relative means the displacement caused by policeman with respect to thief, that is S policeman with respect to thief, right? Here, what is the velocity? Final relative velocity. Final relative velocity of policeman with respect to thief is 0. Now this distance becomes closest distance of approach. Closest distance of approach. CDA. CDA means closest distance of approach. How to get that? CDA means 100 minus S relative. 100 minus S relative. Before that, how to get S relative? We know that V square minus U square equal to 2AX. Am I right? In terms of relative velocity, that is V relative whole square minus U relative whole square equal to into A relative into S relative. Right? Now what is V relative? Final relative velocity of policeman with respect to stationary thief, that is 0, minus U relative. What is U relative? UPT, that is 10. 10 equal to 2 into what is A relative? Relative acceleration of policeman with respect to thief, that is minus 2 into S relative unknown. S relative is unknown, right? So minus cancel here. 2 2 is 4. S relative equal to minus cancel. 10 square means 100 by 2 2 is 4. That is 25 meters. So this is what the relative distance covered by the policeman with respect to stationary thief, right? So this is the S relative, that is 25 meters. Now this is what closest distance of approach, that is 100 minus S relative. So closest distance of approach is equal to that equal to 100 minus S relative. That is closest distance approach equal 100 minus S relative means 25 meters. That is 100 minus 25. That is 75 meters. 75 meters. So this is what closest distance of approach. Okay, friends. With this, I conclude. Once again, I request all the audience to please subscribe channel C Level Physics. Thanks.